that point, as a boy in small town Indiana, I just thought, boy, I just would really love to be a pilot as a career. So I started working in a grocery store. I happened to have a grocer in my town who had his own airplane, and so he was really willing to give me a job, and give me all the hours I needed to pay for flying lessons, and so that worked out well for me. And I got my license early and went on to study aerospace engineering and to become an Air Force pilot. Some of it's just lucky, kind of the way it works out, but I was able to fulfill that dream of being an Air Force pilot and a fighter pilot. And then after some years of that, like test pilot is next. So I was able to combine the academics of the engineering with the operational skills of flying and going to test pilot school, and just kind of found myself in a position where NASA was actually willing to look at the application one day, and they looked at it a few times and put it away before they finally looked at it one time and said, well, we've already hired all the guys that were better than him. They're already here already. So I was lucky enough to get into the Corps at that point. So it just started out with the fascination with flying, really, and I was just lucky to get into the astronaut business.
You mentioned you grew up in a small town in Indiana. Tell us about your hometown, what it was like for you growing up there.
So a small town of about 2,000 people. Just a typical small town that was mostly agricultural. I lived on a farm literally until I was about 5, and then we moved into the city into the center of the small town. And my dad worked in the automotive business and in farming both. And so the friends there were all people who had kind of the same economic status and kind of ideals and stuff as I did, and it was just a nice little town. I went to kindergarten with the same kids that I graduated from high school with, those years later, and so it was a very close-knit community, hardworking, and kind of knew how to take care of themselves, I would say.
Were you able to pick it out as you flew over it on your first flight?
I was not, and the reason is because we launched at about midnight from Florida, and one of the interesting things about orbital dynamics is we had an orbit that took us into the darkness as we crossed the equator northbound and into the daylight as we crossed the equator southbound for the whole 2 weeks. So even though the Earth is rotating underneath you, everything we saw in the northern hemisphere was dark and lit in the southern. So I'll be able to improve on that with a 5-month stay on the space station. I could see, for example, Indianapolis and Fort Wayne and Lake Michigan, Chicago, and tell roughly where it was, but I wasn't able to pick out the town itself, and I'm hoping to be able to do that on my long trip.
What is it about that place and the people that were there that you think helped make you the person that you are?
Well, I think they all thought you could carry your weight and you were capable. Everybody gave you the benefit of the doubt. If I wanted to work in the grocery store and go take flying lessons, there was somebody willing to give me a job doing that. Everybody's pretty hardworking academically and everything. The school was a good example for me academically, and just kind of was willing to boost me out of the nest when the time comes to send me off to college. And it was good to have role models. I knew a lot of the other parents, because I was there with them, all my adolescent life there. I got to know a lot of the parents of the kids and brothers and sisters, and I think all those influences, that stability was a good thing. Was a good thing for me.
You touched on a couple of the high points. Let me ask you to fill in some of the meat on the bones of your education and then your professional career as you left small town Indiana that led you ultimately to become an astronaut.
So you want me to kind of head through my college career after high school, all the way back to there, huh? That was a few years back. So I kind of came out of there. I had a pilot's license actually when I graduated from high school, just because that was my thing. That was kind of my little dream. And I applied for ROTC scholarships and was able to get an ROTC agreement to go to the university and then right into an Air Force commission after that. So I went to Notre Dame. I majored in aerospace engineering there. So it was a lot of, you know, a lot of things to learn about flying in the engineering field too that weren't included in just, you know, getting, let's say, a private pilot's license. So kind of just continued that track. After that, I went to Columbus Air Force Base in Mississippi and became an Air Force pilot. Went through the T-37 and T-30 curriculum. It's about a year. And after the pilot training then, I got assigned to an F-15 in Germany. Between the time you graduate and you actually get there, there's more fighter lead-in training, and then there's some F-15, what we call place-specific training, just learning about the airplane in Arizona that I did, and some survival training and some water and some, you know, POW training and stuff. So about a year later then, I finally got to Germany and flew F-15s in Germany for 3 years. You know, the height of it was 84 to 87, so kind of the height of the Cold War kind of time. Never saw myself in the future flying in a Soyuz at that point, I'll tell you that. And after that, went to Iceland and flew in the 57th Fighter Interceptor Squadron in Iceland for a couple years. Several times joining up on the wings of Soviet Bears, Bear bombers, as they crossed and worked in the North Atlantic. So that was interesting. After that, I went on to test pilot school then in California at Edwards Air Force Base. And after test pilot school, that's a one-year program, in 1990, I went back to Eglin Air Force Base in Florida, back out to the east, and did weapons development testing there for about 3.5 years. So the weapons testing is never boring. We had a lot of really early morning takeoffs out over the sea and doing a lot of tests on the things that didn't work right about maybe 25% of the time. And that was our job, to see if we could make them work right. So that was a very interesting job there. I took a kind of a strange turn after that. I was made aware of a possibility of going to get a PhD in aerospace engineering at the Air Force Institute of Technology. And I had to kind of make a tough little decision there about whether I wanted to go do that or not. And after giving it some thought, I decided to go ahead and do that. So I went to the Air Force Institute of Technology, spent 3 years there doing a PhD in astronautical engineering. And then following that, went to the Air Force Test Pilot School as an instructor. And I stayed there as an instructor. It was a really great job there, but I was coming up on the end of it anyway when I came to NASA. So the timing worked out well, but at the time I was flying gliders with students up in Tehachapi on usually 1 day a week, and the other days I was flying the F-15 and the F-16, teaching students flight test techniques at Edwards Air Force Base. So that was the last job I had just before coming to NASA.
To fly in space, as you're doing now, is to take on a job that has risks associated with it that most people don't ever have to face. Some people would ask you why you do it. I'm going to be one of them. Tell me, what is it that you think that we, all of us, what do we get or learn as a result of flying people in space that you think makes it worth taking that risk?
Well, I think ultimately people want to go to space, you know, and so to get out there, somebody's just got to head that way and put it to the test at some point. Just like when, you know, we expanded across the country and really went to all corners of the earth. I think it's in our human nature to want to do it, you know, yourself as a person, no matter how many times you go to somebody else's slide presentation about their trip to Paris. It's not the same as getting your family, making a big investment in airfare and time off, and really going out there and experiencing that, because we really are all about the human experience. So that's what takes us there. I think an interesting little piece of information is that if you ask somebody, you know, about the first time we went to the moon, few people think about the robotic missions to the moon that preceded Neil Armstrong and Buzz Aldrin and Mike Collins going to the moon. They usually just jump right to the point where, oh, we finally got to the moon. When in reality, we had several robotics missions. The U.S. wasn't even the first one to the moon robotically. So they don't really think about those. Now, those robotic missions are super important to us, and they teach us how to get there. But I think that the human, the emotional connection comes about because we see ourselves out there, we project ourselves out there, and we really want to go explore on our own, have a look with our own eyes.
You're getting ready to launch to the International Space Station for Expeditions 33 and 34. Kevin, what are the goals of your flight, and what are your jobs going to be in space?
Well, of course, the goal of the flight is just to fly a safe and productive flight and carry out, the plan that the increment managers put out there for us. We have a lot of visiting vehicles that will come and go. It could be like up to, including our arrival and departure, maybe like 13 traffic movements and 150 days. So just like one every 12 days, and that adds a lot of overhead to the flight. We have the robotics involved in some of the tracking captures of the new vehicles to look forward to. So that's kind of something we're anticipating. And of course, the progress is coming and going and taking care of the space station. All the purpose of that is really to get the science going. It's now we're in the utilization phase and getting the science rolling at full speed. So we've done a lot of preparation in anticipation of the science we're going to be doing. I'll fly up on October 15th, departing from Kazakhstan with Oleg Novitsky and Yevgeny Tarelkin. And we'll go up and join Sonny Williams and Aki Hoside and Yuri Malenchenko, who have been on board already as part of Expedition 33. And then, unfortunately, some delays in some previous flights have made it so that the overlap with them is only about 3.5 weeks. So we'll have a pretty intense period of handover in there with 33. And then we'll be a three-man crew, Expedition 34 three-man crew for about 3.5 weeks. And then welcome aboard Chris Hadfield, Tom Marshburn, and Roman Romanenko for the Expedition 34 six-man phase, which sometimes we call 34-6. Nowadays, the new lingo, and we'll stay until March. So the goals, we've got some space station maintenance activities planned, some kind of periodic maintenance that we've trained for, but really the emphasis will be on getting the science rolling and getting as much utilization out of the flight as we can.
You've seen this space station before. You were there on your first flight. What are you looking forward to about the space station this time around?
Well, when I was there before, Node 3 was not there yet, and of course with that the cupola was not there, so I'm really looking forward to seeing that. I think though that I'll also look at the space station in a whole new way this time. I was a pilot on Discovery on my first flight, and as a space shuttle crew member, you have a lot of emphasis on the shuttle aspects of the flight and the very high tempo of the shuttle visit. And you don't really get to appreciate all that the space station has to offer. In fact, while you're visiting there, they kind of bring things down to a level so that they can accommodate you as a visiting crew, and you don't really get to see what it's like to live there and work there day to day. So I'm really looking forward to that. I'm looking forward to the extended stay there as well. As a shuttle visitor, you have very, very little spare time. You can measure it literally in hours, a small fraction of a whole day of free time while you're docked. So I'm looking forward to some Sunday afternoons, seeing the whole planet and doing some things I didn't get to do before. And I should mention also that this flight will be in a Soyuz, which for me is a very exciting thing. I was a pilot and test pilot as a profession before coming to NASA. And it was fantastic to get to experience a space shuttle. But I have to tell you, too, that I'm really looking forward to seeing the way a Soyuz operates. It's a whole different way to skin the cat, to get you to space station and get you home. The rendezvous is very different. The flight en route is very different, and the trip home is very different, as you can imagine. So I've really loved learning about the Soyuz, and I'm looking forward to that aspect of the flight as well.
The flight, not just the Soyuz aspect, but a lot of it, it's going to be an excitement to be involved in a project that's making use of the expertise and assets from people all over the world.
Yeah, the space station, this is a great point. The space station is really a huge, very unique cooperative effort between all these countries. We do a lot, and then we got the Olympics coming up, for example, which is an international thing, but it's more, it's a competitive event between nations. And this space station really represents, to me, the very first big cooperative effort between the most affluent nations on this planet coming together to do something all toward one goal. And the space station, because it's made up of components from ESA and from JAXA and the Canadian Space Agency, Roscosmos and NASA. Everybody has a piece of this puzzle. For example, the United States provides power, almost all the power for the space station. We provide this very awesome S-band and Ku-band comm assets, which all the partners use. By the same token, when we want to reboost, the Russian segment provides us with a reboost to space. They provide progress and, of course, crew transportation at the moment to get us there. The Canadians have built the Canadarm2, which allows us to accept these visiting vehicles now, this new generation of commercial visiting vehicles that we have coming aboard. And the science in the Japanese Kibo and Columbus is absolutely, you know, it's world-class science, if you can call it that, since it's off the world. But it's absolutely very classy space station, and I'm really proud to be part of that with all these partners.
You mentioned a couple of the pieces. Fill us in on the rest of what is there right now, so the scene, if you will, that you're going to arrive at.
Yeah, the scene right now is space station, you know, is really all put together. The Russians are getting ready to launch, I think, Nauka maybe through it in a year's time or so, and we'll add one more research module. But we've got essentially 13 or 14 components, depending on, you know, exactly which ones you count up there right now. We have, on the U.S. side, the major laboratories conducting the research. We have Destiny and we have Kibo on the Japanese side, and we have Columbus on the European side. And those are the internal modules where we conduct experiments. On the Russian side, they do a lot of their research in the service modules, Zvezda, and they also do some in Rosviet and Poisk as well. So they have a few smaller research modules to sprinkle their science around. So that's where we're getting all the bulk of the research done interior to the space station. Of course, we have some habitation available to us now. Node 1 is where we do a lot of the habitation functions. We exercise now and we use the restroom and that sort of thing. And Node 3, that's where the regenerative eagles mostly is living nowadays too for our environment control. And let's see, what else we have. On the exterior of the space station now, we have a lot of platforms that have science on them. We have the GEM exposed facility that has some even NASA payloads outside. For example, MAXI, an X-ray, an all-sky X-ray detector on the outside. We're getting ready to take up scan test bed on HTV, which will go on like an external logistics platform out there, and of course, alpha magnetic spectrometer sitting out on the starboard side as well. So the whole thing is this big conglomeration of these plans that have come together for the last couple of decades now, and all out there really getting some good science done. I guess we got that airlock sitting over there too, Quest, just in case we need that. That serves a special function for us. We do some maintenance and keep the suits ready to go so that we can go outside if we want to. And I think that kind of is the big picture of the modules there.
And you point out the pretty broad variety of apparatus that are there for science. How do you explain to people the potential for what new things might be able to be learned in all of those various places?
Well, just being outside the atmosphere, for example, is one step toward getting some science done with the X-ray observatory, with alpha magnetic spectrometer, looking at the space environment in terms of plasma. We're learning a lot just being out there. We're learning a lot just from the fact that we've built this thing. It's an engineering test bed, if you will, for a vehicle that operates and exists in space. The types of materials we've used to build the space station are important to us for when we build a vehicle that actually departs, Earth and goes way far away. Because it's nice to be here just outside our atmosphere. We can make changes if we want, take things up, bring them down. We can send, we have MISSI also as an experiment, which is a materials for ISS experiment that sits outside. And we can put these things outside and look at how materials degrade or or how they weather, if you will, space environment, so we can learn a lot about being out there. The biggest component in my mind still is the microgravity environment, though. The microgravity is just so much different than what we experience here on Earth. You know, from the time you get up in the morning, you can not even open your eyes, and you know where the gravity vector is, and the things you do in your daily life, things like the reason you shake orange juice is because it settles out into layers and that sort of thing. That sort of thing doesn't happen in space. It's just very many unique things, the way convection works and those sorts of things that allow us to be in an environment where sometimes we can see effects that we don't otherwise see down here on the planet. And they're really stumbling on to some really interesting things out there. Sometimes even in experiments where they don't think they will, they might see a phenomenon happen and go after it and investigate it and learn a lot. So it's that really unique environment that is just completely different than down here on the planet.
Now, one of the important areas of concentration in science is figuring out how that environment affects the human body and finding out what the bad effects are and how you respond to them. Give me 2 or 3 examples of the kinds of human life sciences research that you're going to be doing on this trip.
Yeah, so in addition to being working crew members, a lot of times we are asked to be subjects for experiments, and they'll take a really hard look at it before we go, after we come home, see how we've changed, and then in some cases actually can look at us during the expedition as well. I've had, probably tens and tens of hours in MRI machines and stuff to characterize my musculoskeletal system, bone structure, spacing between vertebrae and those sorts of things, and then we'll look at those again when we come back. You can't have an MRI machine in space, but we do have ultrasound up there. We have a spinal ultrasound experiment we're doing where we can look at those distances and send the data back to the ground so that they can see how things change. Does it change early in the flight? Does it change constantly throughout the flight? And that sort of thing. Another interesting thing is that as humans, we're kind of programmed to the length of our solar day. You know, the sun comes up, the sun goes down. Therefore, your circadian rhythm is forced to stay in tune with that. And one of the things they can look at in space where we don't have that normal solar day in orbit, then they can look at how our circadian rhythm would like to flow in some cases with sleep shifting if we didn't have that. So several times in flight, I'll wear a Holter monitor for a test, a Holter monitor to just look at heart rhythms and also my activity and ActiWatch to monitor my activity in space. And then they can look and see how my circadian rhythm was impacted by sleep shifting and get some really good data out of that. One more I might mention is it's not on humans, but it's for humans as a experiment I've been trained to do for JAXA, which is looking at some Medaka fish who happen to have a bone similar to mammals, the way their bone is created and lost. And we'll be looking at these fish in the microgravity environment, and it'll be really great information for osteoporosis research. So that's it's kind of human science, but it's going to be done on the fish in this case.
Well, now, from the point of view of somebody who has spent time off of the planet, one of the few hundred people who have done that, give me a sense of what you think it is we need to learn about how people live in that environment to maximize our chances for being successful when we go out there, when we go further away.
Well, certainly, like I mentioned before, we really need to understand the environment, the radiation environment, all the things about space weather and those kinds of things that we can learn. I think a really big one too is still the human health. If you're going to go to Mars and come home with the current thruster technology and kind of fuels we have, it's going to take a long time to get there and a long time to come back. And I don't really think we're ready yet to go to Mars, land, and get out there and really go to work yet. There's some recovery time involved. We've made some huge steps forward. We have an exercise machine on board now on Space Station that has made a huge difference in the health of astronauts coming home in terms of bone loss and muscle density. But we still have a lot of things to learn, I think, about the neurovestibular and just kind of sensory functions, how to handle those. I'm doing an experiment too. It's an early one called manual control, where I'll fly just before the flight. I'll have a chance in a motion-based simulator to land aircraft, to maneuver a rover on a planet, in a low-gravity planet, do dockings on the planet, and also driving a car. And then I'll do that the day I come home. And they'll compare performance and then recovery time, get some idea of kind of what kind of hits we're taking in terms of, hey, you've been in microgravity now for six months. What kind of tasks can you actually accomplish safely? So all these things are taking us towards humans being able to make this journey. When you get to your destination, be very functional, get a lot of work done, be happy enough to get back on a spacecraft, and of course come back to Earth at the end, having completed the mission. Maybe one more thing too. You know, we're looking right now at some space refueling, fuel transfer capabilities on the space station. Those will be important, you know, from an engineering point of view, to making those kinds of big leaps out to the other places too. So, you know, almost everything we do on the space station, you could point to it and say that is going to help us get to Mars, if that's the next step, or beyond someday.
You touch on a point that I wanted to get you to. There are a lot of modules on the space station that are packed with specialized gear that supports scientific research in disciplines other than human life sciences. Tell me about a few of those kinds of experiments that you've been preparing to work on this flight.
Well, we have, you know, it's really a broad spectrum. I think from my point, I was an aerospace kind of a fluids engineer, so we have a lot of really engineering fluids experiments. One problem we might have now on Earth is if you have a tank that's got fluid and air mixed in it, and you want to, and you're lucky in your car because your fuel is always on the bottom of the tank. We're not that lucky in space. We have to design a tank so that that fuel is always ready by the pump there to be pulled down the line and sent to the engine or to whatever kind of device it's going to drive. So the fluids research they're doing, I think, is very interesting. So we have some experiments set up to do that. Combustion experiments, we all love fire. I think all humans are fascinated by it, and things burn differently in space than they do down here on the planet with the lack of convection and the different mechanism for feeding oxygen to the flame. So that will continue. In the Japanese rack also, one of the things that will continue is a Marangoni experiment, which is they can build a column of fluid very close, very similar to water, between a couple plates that just makes a bridge in space, something you can't possibly do on Earth. You've seen the bubbles that we float sometimes in the cabin, just in a glob, and we like to take our pictures with them and that sort of thing, but they actually do it in the rack. And then by changing temperatures at the ends of the plates, they get flow patterns inside this water bridge. And there are theories about why it happens, but it's still being investigated, and it can make a big difference if it can be applied to spacecraft of the future and stuff like feeding pumps and that sorts of things. You just never know what you're going to find.
Sounds like quite a variety.
There is a wide variety. Every rack is different.
And the scientists who've developed all these different experiments, they come from all over the world too. What's it like for you to get to work with that kind of variety of researcher?
It's very interesting. I just had a briefing yesterday where the scientists taught me here in the U.S., but flew over from Germany just for the express purposes of teaching me about a certain rack. It's the Material Science Lab. And I'm going to be doing some cleaning functions in there in that thing to get it ready for a follow-on experiment. So he came all the way over from Germany as a German national and came to teach me. In Japan, when we're there, the weeks that we're training, they will come from all corners of the country to present to us their vision for their experiment. And of course, for many of them, this is their life effort, the particular research field. The opportunity for them to get to see it happen on the space station, of course, really excites them, and we get to be their hands. So you can see it in their eyes and their enthusiasms. It's a great thing to get to meet them, to really understand what it is that they'd like to do, and we know that they would love to go do it themselves. And you know, maybe someday down the road, we'll be able to get up there and back quickly, and more citizens and scientists can get up there and do their own projects.
The station crew members have got other work to do. Apart from the science, you're the people who are there, and so you're responsible to take care of the station itself. What's a day like for a crew member? What are the kind of things do you have to take care of?
Well, a typical day, we go in a schedule. If it's just a typical kind of science day, we don't have a vehicle docking. That's all driven by orbital dynamics, when it's going to arrive and when it needs to depart. So a lot of that stuff takes you out of the normal day. But if everything is quieted down a bit and you're just on a normal work week, we're going to get up at 6 a.m. At Greenwich Mean Time. So somewhere around midnight or 1 a.m. Houston time, and start our day. And we kind of work a long morning shift, and then an afternoon shift. We spend a good deal of time. They give us, of course, some time for post-sleep activities and hygiene and that sort of thing, just to get ready for the day, chance to have a bite to eat. And then you have a conference with the ground, having take a good look at the schedule for the day, making sure that if you have anything time critical, perhaps a ham radio call with the school at an instant you fly over, then you need there at that point in time, or it's not going to happen. So you want to look at time critical events, things that are coordinated with the ground, make sure you fully understand the day, and gather up tools. Kind of say goodbye to your crew members, because the space station is so big, we can go to all the corners. Now sometimes I've heard that you don't even see other crew members the entire day until dinner time again. So you get out there, and you start turning the wrench in whichever particular rack you have, keeping an eye on the day. And on a typical day, they try to assign 6.5 hours of real, no kidding, this is not preparation stuff. This is actually, you're at the rack getting the work done. So and somewhere in there, a little break for lunch. Also, usually morning or afternoon, the crew members will have an exercise session, which is 2.5 hours of exercise now. So that's what we're up to in terms of keeping our health and fitness. So that's worked into the day. At the end of the day, you have another we call it a daily planning conference in the evening with mission controls all across the world, and talk about the way the day went, maybe a little word about tomorrow, and then some evening quiet time to catch up, maybe make some notes, do a few of the things that you didn't get a chance to do during the day, and then turn in at 9:30.
And you're the ones that
Lights
are
out.
you're the ones who are responsible to hop to anytime something breaks.
Yes.
And it does happen.
Yeah, it does. It does happen. Things do break. Absolutely impossible to anticipate that. So I'm sure there will be a surprise or two in our expedition. Some things that have needed some work in history, then if something breaks on board, you might need to fly it up on a Progress, get a component up there. So there are a few things up there that will meet me when I get there that I've been trained to work on. One of them is the high rate comm system, a new comm system that will multiply by 10 the rate that we can push data to the ground. So that's a big thing. More video channels, more audio channels, and it allows some commanding through the KU band system from the ground up too. So as you know, the state of the art in electronics is changing rapidly. So it's changed a lot since we first designed the space station, and this will be a really big upgrade to get that going. So I've had some training on changing out heat exchangers and the airlock. One of those is kind of like 6-7 years that needs to be done every once in a while, and that's a couple days work. So you go around and pick up those kinds of cats and dogs and make sure you keep the space station in working order.
You mentioned that the time that you're up there, part of it is called Expedition 33, and the rest of it's Expedition 34. And when it becomes Expedition 34, you become the station commander. Does that make your life different than when you were a flight engineer?
Well, I'm looking forward to that time when Sunny is the commander and I'm a flight engineer, learning from her and seeing how everything is run. And I know her very well, and I'm hoping that just everything she does up there, I'm just going to be so happy to do it the same way and continue. So I don't think we'll change station operations one little bit when Sunny leaves. As you know, my crewmates are all could be commanders, of course, themselves. They're all self-starters and very motivated, and excellent technically and very, very friendly to each other and everything. So I don't really have a big job to do in terms of running the shop. My idea, or my primary, my primary goal would just be to monitor the crew, make sure everybody's happy with the tasks they have, things run smoothly with the ground, make sure, if ground's concerned about something, try to help them come up with a plan to kind of get things in the normal again and make things just run smoothly on board. I'm tasked with keeping an eye out for the safety of the crew, of course, and the safety of the vehicle first of all, and making sure we have no compromises on board. So we'll do that, and if anybody has any issues with anything, hopefully they'll bring them to me, and we'll find a good resolution and get back to having the fun that we're really anticipating having. So.
It turns out almost the exact middle of your time on orbit on this mission is going to come right around the Christmas and New Year's holidays. What are your thoughts about being in space on those occasions?
It's not too big a deal for me. I've been in mission control actually on Christmas Day and had a chance to talk with the crews on the holidays, and they love being up there. Probably the biggest thing is asking forgiveness from our families, but they know how special it is, how long we've waited to do this kind of thing, and they'll forgive us this one time around. We hope to have, a little bit of festivities on board. Tried to plan ahead a little bit to have some things up there to make it seem like the holidays. And when New Year's rolls around, I'm gonna do my best to be well rested and try to see some fireworks as we pass through those midnight time zones around the planet and see if we can pick up any of that from space. Yeah, I think it'll be fun. It'll be a nice little break for the 32S crew, my two cosmonaut buddies and I. It'll be kind of about halfway between October, and our come home in March. So it'll be a nice little gap in there, and we'll enjoy it.
The plan for any station increment has to be flexible to accommodate unusual circumstances. You made a reference to that earlier. That includes the need for crew members to have to go work outside. Tell me, as of now, what's the spacewalk plan for your increment? Who would go outside and for what purpose?
Great question. Still shaping up at this point. We are fortunate with Sonny and Aki right now during the 32 time frame are planning to go outside and do EVA 18. So they've been trained to do that. Joe Acaba will still be on board at that point, and if that all goes well and they've taken care of that, then we don't have a scheduled EVA in the 33, 34 time frame at this point. Chris Hadfield and Tom Marshburn have been training to do EVA 18 tasks as well, just in case of visiting vehicles or some other, maybe Sonny and Aki will have to go out and do some other EVA for something more urgent outside. So if those tasks that they're planning to do haven't been done yet, then we'll do those in probably late January, February timeframe with Chris Hadfield and Tom Marshburn. And there's some robotics involved in that. And so my duties would be to suit up IV and work in the robotics for those two guys. At one time we had an EVA 19 in there. I'm hoping it comes back. At this point it hasn't. Chris Hadfield and I trained for EVA 19, and we've been all the way through the EVA assessment, and we're ready to go do that. It's dependent on SpaceX 2 taking up a pair of like picnic-sized tabled radiator grapple bars that come up on the outside of SpaceX 2, and they probably will arrive when we're there. But with the numbers of visiting vehicles, they've decided to go ahead and push that EVA 19 downstream to another expedition further out. It would be taking those grapple bars off and stowing them on the back of the truss using robotics, and just putting those away. So that one left out of our increment. We are all happy to go out. We are doing NBL runs and training in the virtual reality lab for all contingencies, and if the need's there, we'll all be happy to step outside and have a day with a spacewalk.
I think everybody expresses that opinion. I'm ready to go. All you have to do is ask.
Yes.
The space station these days is getting supplies delivered by a small fleet of unmanned cargo ships, and as you made reference, there's maybe a half a dozen or so that could be showing up during the time that you're going to be there. Tell me about those different ships that supplied not only the ships that come from the station partners themselves, but from commercial companies, including a new one, the Cygnus ship that might make its first demonstration flight while you're there.
Okay, yeah, well, we'll just start out with the Progress is the one that comes and goes the most often. When we arrive, 48P will be there, and 49P will get there just after we've arrived and docked to the aft side of the Russian segment. And during our increment, 50P will come and go, and 51P will arrive. So several movements of Progresses on the Progress docking points, ports on the Russian segment. The ATV, the European ATV, is scheduled to have departed before we get there. It's there at this point, and HTV will have come and gone as well, the Japanese vehicle that goes on the Nader Node 2 port on the Russian, or on the US segment Node 2. So that'll be gone. So, and then at the back end of our flight, there will be another launch of a European ATV, and it will be in space when we depart to come home, but it won't have docked yet. So it will be loitering at just a few thousand kilometers behind space station, waiting for us to get out of the way so it can come in and dock. So that's just luck of the draw. We won't see HTVs or ATVs with the current plane. So of course that could always change, and we've had some pretty extensive training on those just in case. So then the other commercial vehicles that are just getting up and running right now are the Dragon, which has made one visit already, and there should be a Dragon on board space station when we dock with our Soyuz, and we should get the chance to see that on board and be there when it's released and it comes back to Earth. Further downstream, right now we're bookkeeping the possibility for another Dragon or Orbital to come at a later date downstream. So about the November, December timeframe, possibility of seeing either one of those vehicles again. Those are both, again, grappled. They fly up underneath the space station just within reach of our Canadarm2 robotic arm. We'll fly over top of a pin and grapple that vehicle and berth it to the bottom port on Node 2, right under the US segment, and have access to the cargo. So we would love to see any of those. Of course, the Dragon had a great flight last time, and one of these days the Cygnus will get up there as well too, and it'd be great to see both of those vehicles during our flight.
And you've trained for that to be the arm operator for those arrivals, right?
Yes, yeah. So we've all of us get a big smattering of training, not only in the grapple itself, but the arrival procedures. We do have a panel to command the vehicle from on board, so we can send it away if we want, or make it hold, and those sorts of things. So we get a lot of extensive training on its rendezvous and its grapple and berthing. So with any luck, we'll get the hands on the controllers at some point and bring one of those aboard.
The landscape of spaceflight has changed an awful lot in just the last few years. You got commercial companies flying, not just governments, and you got sovereign nations working together in cooperation rather than competing with one another. Is that a kind of an arrangement, a model that you see continuing off into the future?
I think absolutely. I see no end to that. I think it's been really kind of an evolution that we won't go back on. So some of those functions, like taking cargo to and from low Earth orbit, NASA has really developed well, in the last few decades, and NASA's about sharing those technologies and making it so that we can do it cheaper, and we can spread out the tasking a little bit and allow NASA to go on and do a few other things that are really more cutting edge, something a commercial company wouldn't dare to invest in at this point. We can do that with our NASA research. And then the international cooperation, I don't see that stopping either. We've made just so many advances in being able to work it out. This is something most people don't appreciate how hard it is in different languages and different cultures with different budgets and different national objectives and different national perspectives, even to bring countries together to make one thing like the space station happen. But I think now that we've seen it, our other big goals, our other big steps out into the cosmos will be as a planet and not just as a nation.
What is it that we're learning on these missions to the International Space Station that's going to prepare us humans for the exploration of space well beyond Earth?
Yeah, just every single thing we do up there, whether it's, again, the materials science for spacecraft development, whether it's communications systems. We have, on the HTV, we have a very large payload going up called SCAN test bed, and it's going to look at a new way to make radios work in space, software-defined radio technology. So we may be looking at kind of even a different concept in how we operate communications in the future. Again, the ability of the humans to not only function in space, but be very functional when they arrive at their destination. Those are the kinds of things we're learning from the science. Fuel technologies, fuel transfer technologies, and all the things we can learn about the space environment are all valuable to us for pressing on out. It is a hard job. It's the most difficult thing an astronaut has to do. Самый трудный.